Have you ever wondered what's going on when we pop our ears and why we have to do it in the first place? And even why it can hurt so bad sometimes? Well, today we're going to find out that much of this has to do with protecting certain structures within your ear, especially your eardrum. And sometimes, if this doesn't work properly, or if someone has certain conditions, it could lead to rupturing of the eardrum. So today we're going to take a look at some awesome anatomy to help us understand how the ear works and therefore answer some of these questions. We'll use this sagittal head dissection that you can see here to look at some really cool anatomy, as well as take a look at Jeffrey's skull, specifically this hole right here called the external auditory canal. And this is part of your external ear. The more superficial part of the external ear, made up of cartilage and skin, has obviously been removed from Jeffrey, but this external auditory canal is where someone might try to put a Q-tip, even though it's recommended that you don't do that. And this is mostly because you might just push in the earwax and any debris further into the ear, causing blockage or impaction. Now, it is possible to rupture your eardrum with a Q-tip, but your ear anatomy has a lot of sensory receptors that can detect pain and discomfort, so most people are going to stop pushing the Q-tip in well before they rupture their eardrum. And speaking of earwax, what is really cool about the skin lining the external auditory canal is that it has modified sweat glands called ceruminous glands that produces this yellowish, waxy, lubricating secretion that contributes to the formation of cerumen, which is the fancy pants name for earwax. Now, earwax provides a sticky barrier to prevent entrance of foreign bodies, such as insects. It also waterproofs the canal and helps prevent the entry of certain pathogens, such as bacteria and fungi. And as an interesting FYI, most people's earwax doesn't build up like crazy. For most, the external ear is self-cleaning and the earwax just dries up and falls out on its own. But there are a select few that produce higher amounts of wax and may require ear irrigations from time to time. But let's keep moving further into the external auditory canal. The external auditory canal ends with the eardrum, or what is technically called the tympanic membrane. The tympanic membrane divides the external ear from the middle ear. The middle ear is actually referred to as the tympanic cavity. And this is a hollow space filled with air and contains the smallest bones in the human body called auditory ossicles. Maybe you've heard their names before: malleus, incus, and stapes. The middle ear also has some of the smallest muscles in the human body, the tensor tympani and the stapedius. The stapedius muscle being the absolute smallest in the human body. But it is this tympanic cavity, or the middle ear, that is very important to our story with popping our ears. But let me give you a quick synopsis on how hearing works. As sound waves enter the external auditory canal, this will cause the tympanic membrane to vibrate. These vibrations will then be transmitted through the auditory ossicles, these tiny little bones, which will then stimulate a small snail-like organ called the cochlea. Sound waves of various frequencies will cause vibrations of different intensities within the cochlea, and this information will get transmitted to the brain through a nerve called the vestibulocochlear nerve. And then we can make sense of and process all the sound. But why are there these tiny muscles within the middle ear? Well, sometimes we're exposed to loud noises, and what these muscles can do is contract and limit the movements or the vibrations of the tympanic membrane to help prevent damage to those inner ear structures like the cochlea. But because it takes a fraction of a second for these muscles to contract, they can protect the inner ear from prolonged loud sounds like thunder, but can't contract quickly enough to protect against brief loud sounds like a gunshot. Now, I'm sure all of you have been super excited to learn all this extra anatomy about the ear, but why do we pop our ears and how does it work? Well, as we have learned, the middle ear is a hollow cavity filled with air, and most of the time it is a closed system that maintains a certain amount of air pressure. And most of the time, the pressure within the middle ear is the same as the pressure outside the body. And the pressure outside the body would most often just be due to the atmospheric pressure. However, sometimes you can get a difference in the pressure between the middle ear and the outside. And this can put tension on the tympanic membrane, which could lead to pain. And if the pressure difference continues to increase, this could even lead to tearing or rupturing of the tympanic membrane. So for example, if someone were to go scuba diving, as they continue to go deeper down in the water, the pressure outside the body would start to become greater than the pressure within the middle ear. And this would cause the eardrum to start bulging inward. And if this continues, again, this could cause pain and potentially lead to rupturing. However, when people are learning how to scuba dive, they are trained on how to equalize the pressure in order to avoid having the tympanic membrane rupture. But let me give you another example. Let's say I decide to drive up the canyon. My house is about at 4,700 feet of elevation, and the nearest ski resort to my house is about 10 miles away. But there is a bit of an elevation change, as the ski resort can get up to 11,000 feet of elevation. So as I head up to the ski resort, I might notice that my ear starts to hurt. And in this case, the pressure that is in my middle ear from being at 4,700 feet starts to become greater than the atmospheric pressure outside, because as I increase in elevation, the atmospheric pressure actually goes down. And this would cause my eardrum to start bulging outward, again potentially causing some pain, but usually this is a pretty quick and easy fix. I either move my jaw around, or I might yawn, or I might even plug my nose and blow with my mouth closed. And I'm pretty sure that I used this hand to touch the cadaver, I think. So what happened when I moved my jaw or yawned or plugged my nose and blew with a closed mouth? Well, this is where the sagittal head dissection will help us with the next part of the story. And this is actually a really cool dissection, as you can see, and most people want to take a look at the brain and the spinal cord, which obviously is very cool, but we've got other videos where we take a look at the brain. But where we want to focus on here is this area, and I'm tracing the pharynx. The pharynx is just a fancy pants name for the throat, and where we're mostly going to focus is the upper pharynx, called the nasopharynx, because it's behind the nasal cavity. And if you look closely right here, where I'm putting the probe, you might see an orifice. And this orifice is the entry into a tube known as the Eustachian tube, also known as the pharyngotympanic tube, which I personally think is a better name because it tells you it's a tube connecting the pharynx to the tympanic cavity, or the middle ear. So there are muscles that surround this opening of the tube. And like I mentioned earlier, the opening is normally closed off. But if we contract certain muscles, and again, we often just do this by moving our jaw, yawning, or again, plugging our nose and blowing with a closed mouth, and this will force the tube to open up. And the pressure that's inside of our mouth and our nasal passageways is the same as the pressure outside. And this helps us to equalize the pressure and effectively pop our ears and take the pressure off that tympanic membrane. Now, most of the time, this system works just fine for people, but all of us have probably had some experiences when this has been a little bit dysfunctional. For example, you may have experienced a time where you couldn't really pop your ears very easily, and you've got what's known as Eustachian tube dysfunction. There are many different causes of Eustachian tube dysfunction. One of the more common causes that I see with my patients is that they had a nasty upper respiratory tract infection, or a nasty cold. And what happens when you get a cold is that these mucous membranes can get inflamed, and they produce more mucus, and it can narrow the Eustachian tube so that it makes it harder to open up and equalize the pressure. This also means that you could get a little bit of fluid buildup in the middle ear, which could just be a little bit of an annoyance, but it could also lead to a middle ear infection. Middle ear infections are referred to as otitis media in the medical world, and they're actually much more common with little kids. And this is because the Eustachian tube, or the pharyngotympanic tube, is more horizontal, shorter, and even more narrow in kids. And this results in two things. One, it's easier for pathogens such as bacteria to make it up from the nasopharynx and into the middle ear. And two, with a narrower tube in a kid, it doesn't take as much to close it off during a respiratory tract infection. So they can't drain their ears as well, and bacteria could build up more easily. Now, what's also interesting about middle ear infections is that your body can actually heal from them on its own, even without antibiotics. And this is a little bit of a debate in the medical community. Should we let people, even kids, try to ride out a middle ear infection, or should we treat them immediately with antibiotics? I think there can be a little bit of a nuanced approach with this, where a pediatrician could assess the child's history, overall risk, and make some decisions with the parent. But one of the potential risks of not treating a middle ear infection is a ruptured eardrum. Will the pus and the pressure build up and rupture the eardrum before the body's own immune system can clear the infection? Fortunately, if an eardrum does rupture, it can heal on its own in anywhere from 3 to 6 weeks. And as a last little FYI, this is why kids who get frequent ear infections might get tubes placed within the tympanic membrane. This allows another drainage point for the pus or the pressure if that Eustachian tube or the pharyngotympanic tube isn't opening up properly and allowing drainage of that middle ear.